All right, guys, this is good enough. First of all, welcome to AGI House San Francisco. I'm so glad you're here. My name is Julius, for those of you who don't know me. I have the honor of running this beautiful place and the honor of hosting events at the frontier, at the edge of science and what the zeitgeist offers. For some context, what is AGI House? Well, we are, you could say, a community, some say a religion. That was started with the intention of, well, building AGI. What a surprise, right? And so in 2022, Jeremy Nixon and Enric Karpathy, our favorite machine learning sensei, got together and were like, what does the best framework look like for building AGI? So they started a house in Hillsborough, known as Neogenesis originally, then named AGI House, and brought together, over the course of those last 4 years, more than 10 unicorn founders as roommates. In fall, we had Antonin from Lovable live with us. Perplexity was started here. So we have like a rich history of very technical problems that were solved. We always try to be 12 months ahead of what the rest of the world is doing, if not more. For example, another friend of ours actually built the first version of agents that interact with your machine, like I think 18 months before like Claude Cowork was actually released, and even before Baby AGI and so on were released back then. And so we hope that today's event brings like a similar excitement in terms of automating research at scale. So you're truly part of something really, really timely and something that pushes the zeitgeist just a bit further, right? Then I would also like to spend some time giving just a tiny bit of context on today's event. Otherwise, Steven's going to set the tone here for us. Steven actually won our Auto Research Hackathon, which we hosted the week and after Enric Karpathy released the Auto Research repo, right? And that's what we do. Something is trending, gets 12 million views in a couple of days, and we flew in actually the Auto Research at Home team from Toronto and New York, had people here innovate in the space, and then you guys won it. So, and now we are like here together at the idea of hosting an automated discovery, scientific discovery event. And I'm so glad that you were leading the way in terms of putting this together for the speaker, in terms of speakers, in terms of content. And yeah, I'm just in awe in terms of how this is all coming together from the community. Having said that, if you guys have a passion, something that's like at the frontier of biotech, robotics, physics, peptides. Last week we helped the California Peptide Club here, which we started, right? Please come find me or message me. We want to do it, okay? So, having said that, welcome again everyone, and applause for Steven. Thank you.
Well, thank you so much, Julius, for that introduction. Hold on, I need to turn on these things. Thank you so much, Julius, for that introduction. I became interested in this idea of automating scientific discovery through work I was doing at my startup. So a little bit of background on, well, I work at a company called Optimal Intellect, and we're developing new ways of accelerating optimization and other numerical methods for the GPU and integrating these with AI pipelines. And I had started to see what was possible in terms of using the AI to develop novel algorithms and sort of novel GPU implementations, and really pushing things towards their absolute limits in terms of what the models are capable of. And this has been incredibly exciting. I'm going to share some of the very cool and in some cases really shocking discoveries that the AI found. And then, yeah, when I saw this, someone shared this auto research event with me, this AGI House Hackathon, and I was really excited to come and see how other people were using auto research and how the approaches people are developing for enabling this sort of mode of interaction with the models, where there's more autonomy, more freedom, and more possibilities in terms of what the models can do. And so the topic, we put together this event on automated discovery at scale. And I really believe this is the frontier of what is possible with these models. In some ways, coding feels too easy now for the models. You need, like, if you want to really push them to their limits, you need to think bigger. And one dimension is this idea of new discoveries in the scientific domain, in algorithms, in math. We've recently seen a lot of results starting to be published across math, physics, chemistry, new algorithms for scheduling compute. It feels like the beginning of something, right? Sort of when we first started to see chat working, first started to see coding working. This is a really promising new dimension for using these models. And one of the ingredients that has to come next is scale, right? It's one thing to run one experiment, one model, get something out of that, but how do you run 1,000, 1,000,000, right? How do you even understand the outputs of that kind of system, right? What kind of practices and communities need to develop to make this possible and make sure that this is something that everyone can benefit from together rather than being just something that a few labs can do. And so this is what the speakers today are going to address. We have a lot of interesting talks about how to run many agents in parallel and develop new algorithms, new designs with different frameworks. We have interesting perspectives on evaluation and benchmarking, and also new ideas about incentives for sharing and maintaining open science in this new world of AI automation. We have 7 talks. It's a packed schedule. But we have a lot of ground we're going to cover. I'm going to start off in a moment talking about my findings for numerical methods, which I think are really exciting and in some cases were quite shocking for me to see. We're going to hear more about evolutionary agents, about the economics of AI-assisted discovery. We're going to hear from the Autoscience Institute about automating ML discovery. We're going to hear about automation of training and inference using research swarms. We're going to hear about DiscoGen, which is a very cool framework that Deepak will be sharing with us, and also about SkyDiscover, another very interesting framework. And then, in addition to all of this, we're going to have a participatory sort of demo that will be us actually doing automated discovery together, or at least our coding agents. So while the talks are going on, this will be running, and we'll get to see what's possible with this kind of approach. Then we'll have some discussion. We have dinner, networking. There'll be a lot of time to chat outside of the events. So in terms of this experiment that we're running together, the idea is we're going to take our local coding agents and we're going to point them at a real research task, and it's about vehicle routing, and it's looking at different benchmarks from a domain expert, so real, like, well-vetted problems. And we've set up a system where the coding agents will share their knowledge with each other, and they can sort of work collectively on this task. So let's start off by getting set up for this. I think this is really going to be quite interesting. This is real sort of research in the sense that we don't know what the capabilities of these models are when we put so many together. So if you can take out your laptop and go to this URL, there's instructions about how to join. So the idea is that you go here, you'll just copy and paste something into Claude Code or Codex or whatever you use, and then you just hit enter, and then that's it. You'll be participating in this group research activity. It's going to be really interesting to see what happens, as I said. We'll later, when we discuss the results, we'll explain more of the details, of what it actually means. But it has to do with vehicle routing and finding the optimal way of doing some sort of like complex delivery problem. Yeah, so go to this link, and if you have any issues, like, let me know. I want to make sure we get a chance to actually do this.